Today we're going to move on to the next step in algebra, solving two-step equations. So just to quickly sum up one-step equations, just to quickly review this, we had basically two or three types, right? We had equations like this, x plus a number, so let's say 5 equals some other number. And what did we do to solve these? If I had x plus 5, I would subtract 5 from both sides, and I would get x equals 5. Then I would plug that in, 5 plus 5 equals 10. That is true. So that's one type of one-step equation. But then we had types where we had no plus or no minus, but we had a number in front of x. So 3x equals 27. And to solve these, this means, you have to remember, 3x means 3 times x. So the opposite of multiplication is division. We can clear the 3's by dividing both sides by 3. And in that case, we get x equals 27 over 3, or 27 divided by 3, which is 9. And again, we can check by plugging in. 3 times 9 equals 27. That's true.
Whenever you do it like an x, like
now, we also had another type kind of like this, right, where we had y minus a number, or an x minus a number, whatever variable, y minus 10, and the opposite of subtraction is addition. So we would have y equals 11 in this problem, y minus 10 equals 1, we add 10 to both sides, so you get y equals 11. Yeah?
whenever you do like 3x equals like 27, I always think that's like 3 times equals 27.
Right. You have to get used to x as being variables, right?
Yeah.
3x. Then we also had this type, right? Where we had like x, instead of times a number, over a number. X divided by 5 equals 5. And the key here is remembering every fraction is a division problem. The way you would read this is x divided by 5. And so to clear off my divided by 5, I'm going to multiply by 5. And I'm going to use this little dot for multiplication since we have an x as our variable. So x over 5 times 5 is just x. And 5 times 5 is 25. So we had addition and subtraction problems, multiplication and division problems. And then the last kind of type was if we had a fraction in front of x. 3 halves x equals 12. You guys remember how to clear when you have an entire fraction as your coefficient?
You put 1 under the 12.
We will need to do that eventually. But to clear off my 3 halves, I'm going to multiply by
2/3.
Exactly, the reciprocal, 2/3. That's going to clear that. I'm going to multiply this side times 2/3. And in these, it's sometimes helpful to write it again, just like this. Right? You could multiply 12 times 2 equals 24 over 1 times 2 equals 3. Or you could just cancel your 3 right away. How many times does 3 go into 12?
4 times.
4, and 4 times 2 is
8.
X equals 8.
Oh.
Okay?
That's 2-step equation.
So that's a one. These are all different types of one-step equations. We subtract to get rid of an addition. We add to get rid of a subtraction. We divide to get rid of a multiplication. we multiply to get rid of a division, and we multiply by the reciprocal to clear a fraction. Okay. Basically, they fall into two types, adding or subtracting, which is what we're doing here. And then down here, this is all really just multiplying and dividing. Why do I say two types? Because adding and subtracting are really the same thing. Subtracting is just adding a negative. And multiplying and dividing are really the same thing. Multiplying is really just dividing a fraction, which is what we see here. Dividing is just multiplying by a fraction. Okay.
No, wait.
So those are two types of one-step equations. Can I erase the top part of this?
Yeah.
Okay.
Yeah. You don't need to write it.
You should be writing everything down that I put on the board. For sure. Write down everything that goes up on the board. So now two-step equations. They look like this. 2x minus 3 equals...
Is that a minus or a negative?
It doesn't really matter. 2x minus 3 or 2x plus negative 3, you can think of it either way. But you would read this as 2x minus 3 equals 7. Right? It wouldn't make sense to say 2x negative 3. There's nothing happening there. Now, if I had a parentheses, like if I had written this, that would be 2x times negative 3, right? Which is a totally different equation. That's not what we're doing. So here's a two-step equation. 2x minus 3 equals 7. Now you probably see there's two things that we need to do. Here we have minus 3, so we're going to have to add 3. And here we have 2 times x, so we're going to have to divide by 2.
Nate, where's our letter?
But which one do we do first?
Wouldn't it go by PEMDAS?
Okay, really good. So it's going to go by PEMDAS, but it's going to go in the opposite order of PEMDAS.
Oh, because it's a negative.
So the reason it's going to go in the opposite order is because we're trying to undo what's already been done. Okay? And you'll see this when we check our problem.
Oh no,
When we check our equation.
So yeah, we do it sad.
So the first things we're going to do are addition and subtraction. So what would we do first in this equation?
Minus 3.
Except we want to do the opposite. We want to reverse everything, right? So we're going to add 3 to both sides. Now we have 2x equals 10. You guys know how to solve that. But if we pay attention to PEMDAS, we did our addition and subtraction. Now we're going to do our multiplication and division. So we have 2 times x. What do we need to do to get x alone? Divide by 2. 2x divided by 2 is x, and 10 divided by 2 is 5. Now let's check that. So if we plug x in here, we have 2 times 5 minus 3 equals 7. And you see how I plugged it in parentheses? That's a good rule. You want to start getting used to just plugging in your numbers into parentheses. Let's check this. So now, since we're solving it, we're going to follow the order of operations. We're going to follow PEMDAS. Right? So the first thing we do, because we're solving an equation or because we're evaluating an equation, is 2 times 5, which is 10. So now we have 10 minus 3 equals 7. And 10 minus 3 does equal 7, so that is true. So when I plug it back in, I have to follow PEMDAS. I'm evaluating an expression. I have all numbers. In order to get this answer, though, I'm reversing everything. I'm going backwards, and that includes reversing PEMDAS. So let's do a few examples of these.
Pizza.
Example 2. 3y minus 1 equals 5. What am I going to do first?
You're going to add 1.
Add 1 to both sides.
You're going to get 2 and 6.
3y equals 6. The 3 is not going to change because adding 1 just took care of my negative 1. 3y minus 1 plus 1. That's 3y equals 6. Now what do I do?
You divide 3 on both sides. And get 1.
Divide both sides by 3. So I get y equals 2. And I could plug that in. 3 times 2 is 6. 6 minus 1 is 5. So it would work if I plugged it in. Alright. Example 3. What if I had 4x plus 1 equals 9?
You subtract 1 on both sides.
Good. First step, subtract 1 on both sides. What do I have over here?
4x.
Yeah, my 4x is still left. What do I have over here?
8.
Next step.
You divided by 4 on both sides.
Yes. Very good. What's over here?
X.
And 8 divided by 4 is
2.
pretty straightforward, right?
Yeah, it's actually really pretty.
Okay, there's a couple tricks when you start to see division in your problems. So I want to talk about that.
Isn't the opposite of that multiply?
What?
Isn't that like if you like divide by 3, you
Yeah.
times 3?
Yeah, like let's look at this one. X over 3 plus 1 equals 1.
Minus 1.
Okay, first step, subtract 1 from both sides. We have x over
3
equals
1 minus 1 is 0. Now what am I going to do to get x all alone?
You have to
Multiply by 3. So x would be 0 times 3, 0. Okay? Not too hard. Just remembering that multiplication and division are opposites. Remembering this means divided by 3. What if I had, let's do another example like this. X over 5 minus 2 equals negative 1. First step.
You add 2 on both sides.
Add 2. What's left on the left?
X over 5.
So over 5. Very good. Negative 1 plus 2.
Negative 1 plus 2 is 1.
Positive 1. Okay. Same thing as 2 minus 1.
And then you multiply by 5.
Then I multiply by 5 on both sides. So I have x equals 5. Very good. And I could plug that in. X equals 5, so 5 divided by 5 would be 1. 1 minus 2 would be negative 1. So that would check if I plugged it in. And I want you guys to do that on your homework. Take this number and actually write 5 divided by 5 minus 2 equals negative 1. And simplify this. 1 minus 2 equals negative 1. Negative 1 equals negative 1. Okay, we've checked it. We've actually written it in and done the math again to check it. All right, what if we had a whole fraction like this? 2/3 x plus 1 equals 13. Subtract 1 from both sides. What's left on the left? 2/3 x. I got rid of this extra number here. 13 minus 1 is?
12.
13 minus 1 is 12. Now what do I do to get rid of the 2/3?
Times
Times
2/3. 3/3.
3 halves. The reciprocal. 3 over 2. And again, when I have these fractions like this, I would rewrite them. X equals 12 over 1 times 3 over 2. Okay? This is going to be really helpful if you can remember to do this. The 2 will cancel with a 12, leaving 6. 6 times 3 is 18. What if, another example of that, what if I had negative 3/5 x plus 1 equals 10?
You would subtract 1 by
Subtract 1. You guys are getting the hang of this. Negative 3/5 x equals 9. Now what do I do? So I have 3/5 times x. I want to multiply.
Multiply by 5.
By
the
reciprocal.
Okay. The trick is it's negative 3/5, so my reciprocal is still going to be negative. Okay? So I have negative times a negative equals a positive x. And then I have 9 times negative 5/3. Let's rewrite that. 9 over 1 times negative 5 over 3. My 9 cancels with my 3, right? Giving me 3 times negative 5, or negative 15. X equals negative 15. And they don't necessarily have to always work out perfectly, right? What if I had 7/9 x minus 1 equals 2? Let's solve this. Actually, let's make it be negative 2. No,
You add
negative 7/9.
Okay.
Put some more negatives. Okay, first we
add 1.
okay, negative 7/9 x equals 3. What's my reciprocal of negative 7/9? Negative 9 over 7. If you have room, I like to write them like this, right from the get-go. Because then I can see negative times a negative is a positive, 9s cancel, 7s cancel, so I just have x. And then I'm going to rewrite this, 3 over 1 times negative 9 over 7. What is 3 times negative 9/7? What am I going to do? When I'm multiplying two fractions, I multiply the numerators, which is 3 times 9, 27. Is it positive or negative?
It's negative.
Right, because a positive times a negative is a negative. Multiply by denominators. 1 times 7 is, so I have x equals negative 27/7. Sometimes they'll work out like that. They're not always going to be integers, right? They could be fractions in their answers. The only thing I want to check is, do I have anything that goes into 7 and 27? In this case, I don't. So this is a reduced fraction, and it's okay to leave it as an improper fraction. We don't have to turn it into a mixed number anymore. Okay. One more trick. So if I erased it before you got it, just look at your neighbors. they will happily and kindly and compassionately share. So what if I had this though? This is the one last trick. X plus 1 over 5 equals 2. What does this mean?
Oh, let's try this by ourselves first.
What does this mean? X plus 1 over 5 equals 2.
Okay, I don't know this one.
So we've been talking about always subtracting or adding first, but that's not actually what I said, right? What I said was we want to reverse PEMDAS. Now the trick here is if you think about what this means, it means x plus 1 all divided by 5. If I were to write this out, it would, like in one line, it would look like this. In other words, there's an imaginary parentheses around my numerator. There's always an imaginary parentheses, right? That's around this numerator, even without writing it. So then what we have to remember is parentheses is the first step in PEMDAS. If we're reversing PEMDAS, that's going to be the last thing that we get rid of. So in a problem like this, the first step is to multiply times our denominator. Times 5. Those are going to cancel, leaving me with x plus 1 equals 2 times 5, which is 10. And then I can subtract my 1. Because I had these parentheses here when they were in the numerator. Now that it's all alone, I don't need those parentheses anymore. So I would subtract 1 from both sides. X equals 9. I'll do a second example. What if I had x minus 3 over 2 equals 1? Multiply this times the denominator because of my imaginary parentheses up here. So I'm going to multiply it times what number?
By 2.
Times 2. Then I multiply this side by 2.
And then x minus 3 equals 2.
X minus 3 equals 2. Then what do I do?
You add 3. But then you get x equals 5.
2 plus 3 is...
Yeah.
Very good. And then we could plug this in. Watch what happens when we plug these in. I'm going to have 5, because that's x, minus 3 divided by 2 equals 1. The way I would solve this is to do my numerator first. 5 minus 3 is 2 divided by 2 equals 1, which is true. 2 divided by 2 does it. So when I check it, it works out. If I had not done it correctly, if I had first added 3 to both sides, I would have gotten a different answer that wouldn't have worked when I checked my problem. Okay? Beautiful. 2-step equations. Checking your work, fractions. There's a lot to go over in one lecture. Do you guys have any questions?